వెల్కమ్ టు ఇండియన్ టెక్ గ్రూప్ ఫర్ యూ. ఈరోజు మనం యూజీసీనెట్ జూలై 2018 క్వశ్చన్ పేపర్లో ఆపరేటింగ్ సిస్టమ్ సంబంధించిన క్వశ్చన్స్ ఆన్సర్స్ విత్ ఎక్స్ప్లెనేషన్ చూద్దాం. మొదటి ప్రశ్న, అట్ ఎ పర్టికులర్ టైమ్ ఆఫ్ కంప్యూటేషన్ ద వాల్యూ ఆఫ్ కౌంటింగ్ సెమాఫోర్ ఈస్ 10. సెమాఫోర్ వాల్యూ ఎంత ఇచ్చారు? 10 అని ఇచ్చారు. దెన్ 12p operations and xv operations were performed on this semaphore. If the final value of the semaphore is 7, final value of semaphore is 7, then x will be. This is the question. So we should know what is p operation and what is v operation. P operation represents weight operation, weight of s, and v represents signal of s, signal of s. So we already know that weight of s, whenever weight of s is initiated, then the semaphore value will be decremented, decrement semaphore, and whenever signal operation is initiated, then increment semaphore s value. Okay, so initially the value of a semaphore is, counting semaphore is 10. Then how many operations are of p were implemented? 12 operations. That is why we have to perform decrement 12 times, so which is represented as a minus 12. So now s will become 10 minus 12, that is equivalent to minus 2. After that, xv operations have been carried out. V operation represents signal of s, which is going to increment the semaphore. So how many increments? X increments. So that is why at present the semaphore value will be minus 2 plus x, and the resultant value they have given as 7, the present current semaphore value. So minus 2 plus x will be equivalent to 7. X will be equivalent to 7 plus 2, that is equal to 9. They have asked for x value. X is 9. So answer is 2. See the next question. In a paged memory, the page hit ratio is 0.40. What is the hit ratio? Hit ratio is 0.40. The time required to access a page in secondary memory is equal to 120 nanoseconds. Access time of secondary memory is equal to 120 nanoseconds. The time required to access a page in primary memory is 15 nanoseconds. Access time of primary memory or main memory is equal to 15 nanoseconds. Then we need to find the average time required to access a page. Average time required to access a page. That is, we need to find out the average access time. Okay, very simple. So average access time formula is hit ratio multiplied by access time of primary memory plus 1 minus hit ratio into access time of secondary memory. So this is the formula for calculating the average time required to access a page. So what is the hit ratio of hit ratio? 0.40. So 0.4 into access time of primary memory is 15 nanoseconds plus 1 minus hit ratio is 0.60 multiplied by access time of secondary memory is 120 nanoseconds. So 0.4 into 15, that is 15460. So 6 plus 0.6 into 120, 72. That is equivalent to 78. So what is the answer? 78 nanoseconds. See the next question. In a multi-user operating system, 30 requests are made to use a particular resource per hour. So in 1 hour, how many requests? 30 requests on an average. The probability that number of requests are made in 40 minutes when arrival pattern is a Poisson distribution is. So here you may observe that in 1 hour 30 requests means in 60 minutes 30 requests are made. So we need to find the probability for 40 minutes. In 40 minutes, how many requests are made? 40 into 30 by 60, cross multiplication. 40 into 30 by 60. So how many requests? 20 requests are made. So in Poisson distribution, the formula for arrival pattern is e power minus lambda multiplied by lambda power x divided by x factorial. This is the formula. So here the number of requests that could be sent in 40 minutes represents the lambda value. Lambda is equal to 20. The actual number of requests that are sent in 40 minutes will become 0. So x value will be 0 and lambda value will be 20. Now we can find the arrival pattern because it is a Poisson distribution. Just substitute in the formula e power minus lambda. Lambda value is 20. E power minus 20 multiplied by 20 power 0 divided by x factorial 0 factorial. 0 factorial is equal to 1. 20 power 0 is equal to 1. So the answer will be e power minus 20. Answer is 4. Next question number 54. Normally user programs are prevented from handling IO directly by IO instructions in them. For CPUs having explicit IO instructions, such IO protection is ensured by having the IO instructions privileged. In a CPU with memory mapped IO, there is no explicit IO instruction. Which one of the following is true for a CPU with a memory mapped IO? So here we need to answer this question by thinking logically. So whenever there are IO instructions, explicit IO instructions, IO protection is ensured by having IO instructions privileged. IO instructions privileged. For example, if you consider a keyboard, it has completely IO instructions, so they will have privilege. So in a CPU with the memory mapped IO, there is no explicit IO instruction. Then who are going to take care of the IO instructions? So the first answer is IO protection is ensured by operating system routines. So let us come to this answer afterwards. The second answer is IO protection is enabled by a hardware trap. This is wrong because if it is IO instructions privileged, then we are going to have a hardware trap. IO protection is ensured during system configuration. This is also not correct. IO protection is not possible. This is also not correct. Definitely IO protection must be provided. So that will be taken care by the operating system routines. Because in a memory mapped IO, the CPU is busy with memory mapped instructions. So the protection must be provided by the operating system routines. Basically, there are three categories of IO operations: programmed IO, memory mapped IO, and DMA. In case of programmed IO, IO protection is ensured by hardware trap. In case of memory mapped IO, IO protection is ensured by operating system routines. In case of DMA, there will be separate IO processor which is going to provide the IO protection also. So the answer here is IO protection is ensured by operating system routines. Next question, which Unix or Linux command is used to make all files and subdirectories in the directory procs executable by all users? So here the answer is we'll be making chmod represents change the module, and here hyphen or a plus x. A represents all programs, and x represents the subdirectories also. So what is the answer? Chmod change mode to a plus x. A plus x means all programs. So it is going to represent the users as well as the groups as well as the owner are going to access executable. That is, all users are going to uh, execute the programs without any problem by changing the mode to hyphen or a plus x programs. So this is the answer. Next, question number 56. Which one of the following statements are true? External fragmentation exists when there is enough total memory space to satisfy request, but the available space is contiguous. So if the available space is contiguous, then external fragmentation will not occur. But here the statement is contradiction. If the space is contiguous, then no external fragmentation will arise. So this statement is false. For example, assume that this is the main memory. Assume that here 40 KB of memory is available, and a new process has come, process P3, which require 35 KB. Then this 35 KB P3 process can be accommodated into 40 KB. So because 40 KB is a contiguous memory, we can allocate it. There will not be any external fragmentation. Whereas assume that you are having two holes of 20 KB and 20 KB and 15 KB, which are not contiguous. Here 20 KB is there and here 15 KB is there. So even though 35 KB is available, because it is not contiguous, we cannot accommodate process P3, then external fragmentation will occur. So A, statement A is false. Next, statement B, memory fragmentation can be internal as well as external. That we know two types of fragmentation is there, internal fragmentation as well as external fragmentation. One solution to external fragmentation is compaction. So it is also true, because here you may find 20 KB, 15 KB. If you bring this 20 KB and add this to 15 KB, then it will become 35 KB, and you can accommodate process P3 to this particular block. So then external fragmentation can be eradicated. So what is the answer? B and C only. Next question, page information in memory is also called as page table. The essential contents in each entry of a page table is or. So in a page table, what will be the contents of page table? There will be two contents. One is the page frame number 0, 1, 2, 3, 4. So it contains the page frame number. So for example, for 0 page, which frame is allocated? Page number 5, frame number 5. For 1 page, frame number 10. For 2 page, frame number 4. For 3 page, frame number 2. For 4 page, frame number 1, something like that. And there will be one more bit, valid, invalid bit. Valid, invalid bit. They didn't ask for that. So what is the contents of the page table? Page frame number. Page frame number is the content of page table. Next, question number 58. Consider a virtual page reference string, and they have given one reference string. Suppose LRU page replacement algorithm is implemented with 3 page frames in main memory. Then the number of page faults are. We need to find the page faults. So what is the Main memory size 3 frames. 3 frames are there, and you need to write the page reference string 1, 2, 3, 2, 4, 2, 5, 2, 3, 4. So initially, because there are empty frames, there are empty memory, you can accommodate 1. Next, you can accommodate 2 also. Next, you can accommodate 3 also. 1, 2, 3, and then we need 2. 2 is already there, so no need to replace. Next, we need 4. 4 is not there. So which one to be replaced for bringing 4 into the main memory? So already 1, 2, 3 are there. Least recently used. We need to use the recently used algorithm. So what is the most recently used? 2 is most recently used. 3 is next most recently used, and then 1 is least recently used. So replace 1, then it will become 4, 2, 3. We need 2. 2 already there. We need 5. 5 is not there. So among 4, 2, 3, which one is the least recently used? Most recently used is 2, and then 4, and least recently used is 3. So replace 3, then it will become 4, 2, 5. 2 already there. Now we need 3, which is not there. Among 4, 2, 5, which one is most recently used? 2 is most recently, and then 5, and then least recently is 4. So replace 4, 3, 2, 5. Now once again we need 4, which is not there. Among 3, 2, 5, 3 is the most recently used, 2 is next, and 5 is least recently used. So replace 5, then it will become 3, 2, 4. Now count the number of page faults. 1, 2, 3, 4, 5, 6, and 7. So total 7 page faults have occurred. So answer is 7. Next question, consider the following 3 processes with the arrival time and the CPU burst times given in milliseconds. They have given 3 processes and given the arrival time also. The Gantt chart for preemptive SJF scheduling algorithm is: preemptive means you can stop currently executing process and allocate the next process whenever it is required. So arrival time 0 means only at arrival time 0, at arrival time 0 only process P1 is there, so we need to allocate process P1 first. After 1 millisecond, in the ready queue, there will be P1 as well as P2, and after 1 millisecond, P1 completes 1 millisecond of execution and the remaining time will be 6. However, P2 requires only 4 milliseconds, so we need to stop P1 and allocate P2. So now here in the second diagram we have stopped P1 and started P2. So after 2 milliseconds, P1, P2, P3, all the 3 processes will be there. So the remaining time for P2 will be 3 and P3 will be 8. The required time for P3 will be 8. However, because P3 requires more time, P2 shall continue execution. So we can continue P2 from 1 to 5. After that, P2 will be completed. And now comparing P1 and P3, P1 requires shortest execution time. So start with P1, 5 to 11, and finally P3 from 11 to 19. So what is the answer? 2 is the answer. This is the correct Gantt chart. See the last question, in operating systems, in which of the following scheduling criteria context switching will never take place? What is context switching? Stopping the currently running process and allocating another process is called the context switching. So context switching is done in preemptive schedulings. Round robin is by default preemptive scheduling, and they have given 2 preemptive schedulings. So only the non-preemptive scheduling they have given is non-preemptive SJF. So answer will be non-preemptive SJF. So these are the operating system questions that have been given in July 2018 question paper. Some of the questions are tough, some of the questions are easy, some of the questions are very easy. So this is the second video. We have already discussed the December 2018 question papers operating system questions. Next, we will continue with the previous question papers operating systems. After operating system is completed, then we will start with another subject. This series will continue till the UGC net exam is conducted. So stay tuned and subscribe our channel as well as touch the bell icon so that you'll get notifications whenever I upload a new video. That's all for now.